So a semi-confined aquifer, that is a layer through which water can pass in and pass out. So one side of the aquifer is permeable, but the other side is impermeable. I want to introduce two interesting concepts here. What is aquaclude and what is aquatard? Aquaclude is an impervious confining layer, and aquatard is a permeable confining layer. So porosity is also very important because that's the spaces in the substrate where the water goes into. So porosity is a measure of the size of the number of spaces in the substrate. If we look at this picture, that will help you to understand what is unconfined aquifer. We have this Vedas zone here and the water table. This is under atmospheric pressure. And unconfined aquifer got charged by rainwater and the surface water. It's called unconfined aquifer. That means both sides of the aquifer is permeable. And the semi-confined aquifer, one side is aquatard. This layer of substrate is permeable, and the aquaclude, that is not permeable. Okay, that's impermeable rock. So the semi-confined, now you can understand the word. What does it mean? That it means one side it can go in and out, the other side it cannot. It was impermeable surface. It was locked here. And the confined aquifer, the water is locked between the two impervious layers. And aquaclude means impervious layers. So the water can only flow this way, and that way it cannot go in and out of those layers. So to reveal, it's a little bit hard to understand, I know. So we come here and reveal again. What is aquifer? Water entering the soil, either taken by plant roots or moves downward until it reaches an impervious layer of rock, and accumulates in porous strata. Those areas are called aquifer. An aquifer is an underground layer of gravel, sand, or permeable rock that holds groundwater that can be extracted by wells. And a confined aquifer is bonded on top and the bottom by layers impermeable to water, and the semi-confined aquifer is the confining layers through which water can pass in and pass out. So water in these aquifers is stored under high pressure and recharged by rain and the surface water from a geological recharge zone. Now thinking about Yellowstone, wolves, when wolves were reintroduced, it restored the vegetation. And the vegetation helped the soil to retain the water and to help the water filtering through the soil and recharge those aquifers. That's why soil erosion is not a welcome in environmental science. Human influences on the hydrologic cycle, because of the increase of urbanization and tourism, we profoundly changed the climate because of global warming, ocean salinity, acidification, sea levels, especially precipitations, extreme weather, ocean currents were affected. All were affected. And we cut off the forest, right? Significantly impact evaporation, evapotranspiration, runoff, and the infiltration. Overdrawing water from rivers and the groundwater, so most of the rivers were gone. 50% of the rivers all over the world were not existing anymore. And when the storm come, when the flooding come, we overwhelm our city system. And sometimes we mix the storm water with wastewater. That will make situations even worse. That spreads the contamination. And because of the buildings, because of the parking lots, shopping malls, we dramatically change the surface of the planet and make it impervious, right, impermeable. And that causes flooding. That makes the flooding and the storm even worse. So to summarize how we use water as humans, we use water for domestic purpose, agriculture purpose, and industrial purpose. So this is my focus. Another focus, I want you to focus on domestic use and the use of water and contamination. It doesn't mean agricultural contamination, industrial contamination are not important, but I will just test the domestic use of water in the exams and in the final exam. The average person in North America home use approximately 400 liters, 100 gallons of water per day. 1 gallon is 1 jug of milk, so think about 100. That's a lot. 6,900 used as solvent to carry wastes. So this is very interesting. We use majority of the water cleaning, washing and cleaning, and 30% used for lawn and garden, and 2% used for drinking or cooking. So actually, the water goes into our body is not the majority of the water we use. This is a pie. I want to emphasize on this pie. We can see how we use the water in the visual manner. And we can see for toilets and bathing and the laundry, this is a big portion of the water used domestically. And the drinking and cooking only 2%, right? The washing dishes also belong to this big portion of cleaning and washing. And the lawns, 30%, that's a lot. At first, we do not think it's a lot compared to this, right? But compared to the drinking and the cooking, that's 15-fold. So if we can save water here, right? Water our lawns smart and smartly choose our plants, we can save a lot of water here. And of course, I want to say go green actions. I very possibly will test this because this is important. And for this, I want to challenge you. How can you think of 3 go green actions to save water? Such as turning off the water when you brush your teeth, right? When you can take a shower, you skip a bath. When you can take a shorter shower, you do not take a long shower, things like that. Just try to think about those things as individual. How can we save water? Each individual is significant. If each person keeps saving water, we can save a lot of water all over the world. So the issue is the natural processes cannot cope with high concentrated urban wastes and must be treated before release. And we have this huge contamination problem because there's a lot of wastewater discharge not thoroughly treated. So a lot of chemicals were found in a majority of the water samples. And now thinking about saving water, okay, so that is a slide of contamination. This is a slide of saving water. Public attitudes mainly leads to water loss. A lot of people think we have a lot of water, we don't need to save those. And that is the main reason, that's the main reason why so much water is wasted. And the water crisis will be escalating in the next 10 years in North America and all over the world, as I showed you in the slide. So this is a study slide that means a lot of details, but you can take your time at your own convenience to read those details if you cannot catch up with me.